Problem 1 of simple band brake. So example 6.32. A simple band brake of drum diameter 600 mm has a band passing over it with an angle of contact 25 degrees, while one end is connected to the fulcrum, other end is connected to the brake lever at a distance of 400 mm from the fulcrum. The brake lever is 1 meter long. The brake is to absorb a power of 15 kilowatt at 720 rpm. Design the brake lever of rectangle cross section assuming depth thrice its width, assuming allowable stress 80 MPa. So diameter of the brake drum is 300 mm. So half of it, radius of drum is 300. So angle of contact is 225 degrees. This angle of contact. And then power is 15 kilowatts. Speed is 720 rpm. The thickness of the brake lever is 3 times width. Then the allowable stress of the brake lever is 80 MPa. So here there is nothing. So you have to design for the brake lever and not for the band. So just you have to find the width and thickness of the lever. There is no data of band, so we can skip the design of band. Now here this is a brake drum as shown in the figure. So this is 225. I just said that the one end of the band is connected to the fulcrum, other end is connected to the brake lever at a distance of 400 mm, and the brake lever itself is 1 meter long or 1000 mm. So this is the figure. First we need to draw the figure. So apply the procedure. So by the procedure, first find the torque transmitted, that is MT equals to 9550 1000 N by N. So therefore we get the torque transmitted. So that is 9550 N by N. So we get it as 198,958.33 Nm. So then we get the next to find the actuating force. So next second procedure to find the actuating force F. So actuating force F, MT equals to F theta into R. So this we get MT is known, R is known, so we get F theta. That is MT is known, R is known, so we get F theta equals to 663.2 newtons. So next find the e to the power mu theta in separately. So e to the power mu is 0.3 given. If not given, you can assume it as 0.3. So here it is assumed as 0.3 now. Then theta is 225 into pi by 180 radians. So we get 3.2482. It's e to the power mu theta value, assuming mu as 0.3 if it is not given. Now use the formula for the simple band brake. So use both formulas, clockwise and counterclockwise. So clockwise formula and counterclockwise formula. So it's substituting the values of F theta, B, A, and mu to the mod mu theta. So this formula and this formula. Find both the F and assume the maximum one. So find both the F, assuming the maximum of these two. So the maximum is 383.3 Newton. So now so since there is nothing, so there is no values given for the, so you have to skip this. So no need of a band because there is no data given. So skip this to the design of lever. So now design of lever. So they have allowable stress is already given, that is 80 MPa. So allowable stress is already given, that is 80 MPa. So no need of this. Then it's already given 80 MPa. Now bending moment is MB equals to F max into A. So bending moment MB equals to F max into A, that is 383 into 1000, that is 3300 Newton mm. Now I is B1 H1 cube by 12. B is width, H is thickness of the lever by 12, cube 12. So assuming it is 3 times the width, so they have said that. So H is 3 times the width. So substituting H as 3 times the width. Substituting this here instead of H1, substituting 3B1 cube 12. So H1 by 2. C is half of the width. So half h, c is h1 by 2, so 3b1 by 2, that is 1.5 b1. So here it becomes 3 cube is 27, b1 b cube and b1 becomes b4 by 12. So c is h by 2 or 3b by 2, 1.5 b1. Substitute the values of in the bending equation. This is the bending equation, m by I sigma by c. Substitute the values of mb I sigma b, that is the allowable stress in the brake lever, upon c. So we get that b1 as 14.277. So b1 is this much, therefore h1 is 3 times the b1, that is 45 mm. So this was about the problem 1 of simple band brakes.